Before we wander over to the review, I want to talk to you about what I've put on my slide this week. I've got the review posted there, and I changed the review. I cleaned it up, neated it up, made it more like what we need on Saturday, I think. So if you printed it off before Saturday, there'll be some changes, and I'll let you know. Um, Other things I put out there, our deadline for my math lab is Thursday night, and the deadline for the test is Friday night. That's not changing. I will leave the review open the whole time. I'll just grab the hundreds off of there on Friday morning when I grab everything else off. So the review will be a little more fluid. You'll be allowed to look at the review all the time. There won't be that gap on Friday morning, early Friday morning. Other things I left for you, there is a STEM workshop, a STEM meeting kind of thing, virtual meeting. It's the 8th, so that's next week sometime. Kristen Hemingway at Trinity River is running it. She's the math department chair. She is so fun. She's a good friend of mine. She used to be an adjunct at Northeast, and she has gathered 3 or 4 people who work in STEM field, and they're just going to talk about what they do and answer questions. And there are prizes. And then another thing I left you with is a 30 some odd page. Oh, that's fine. That's fine, Christine. I'm glad you're here. It doesn't matter which one you come to at all. So there's also a second STEM field thing saying, what do I do if I've got that job? And they're like 30 people. They've got it's a pretty brochure. If you'll click on that one, they've got done tons of jobs listed that you would do if you had an applied mathematics degree. And then they profile like 30 people and go through what they like about their job, the pros and cons, what they actually do, where it could lead, their salary. It's really a slick brochure, the bottom one on my slide. And then, because last semester I pushed voting, this semester I'll push vaccination. So I've got the link so you can register to get your vaccination, because everyone in the state is eligible now over the age of 16. I've got the eligibility link for Denton County, not eligibility, the registration link for Denton County and for Tarrant County. You don't have to live in a county in order to register there. In fact, what they're saying is register in every county that you're willing to drive to. Erath County, Stephenville, that direction, southwest of us, has tons of vaccine. There's always availability there. So if you want to drive that far, hour and a half, register there. But Denton County is up at the Speedway. It is stay in your car the whole time. It is run like a well-oiled machine. There's such praise for that site. They're running 11,000 vaccines a day. So think about registering in Denton County. Even though you don't live there, it's not a problem. They want you to register everywhere you're willing to drive. So I put up the registration pages for both Denton County and Tarrant County. Be honest. If you're 20 years old and you have nothing wrong with you, say that. They're going to get to you. Today is the first day they can vaccinate anybody, and they're pouring vaccines into the states, and they will get them in arms as soon as you do that. If you object to that, don't tell me, because I'm a math and science person. I believe strongly in it. So yay for you. But I know we need to get us crap, and the way to do it. And in fact, Wednesday I get my second shot. So Wednesday is a great day for me. Okay. I haven't seen my grandchildren in a year and 2 months, and FaceTime doesn't cut it when you're 2 years old. So here we go. We have done all this material. We're doing the review today. You know your deadlines. Wednesday we will cover 5.1 and 5.2, most of 5.2. Okay, so let's hit the review. I changed up number 1 a little bit. I wanted to include a little bit more detail. So let's look first at the one that is printed on number 1. It talks about this graph. As x goes to negative infinity, so we're going along the x graph looking for negative infinity. Well, on the x-axis, negative infinity is way over to the left. So I'm going along here and seeing that this piece of the graph is what I need to be looking at. So as x goes to negative infinity, as we are going further, -5, -6, -7, -8, it's asking you what the y is doing. And you can see that on the y-axis, we're getting closer and closer and closer to 0. We're getting down there to 0. So this arm, this is like, this point right here would be -5, 1/2. This point is -6, a little bit less than 1/2. This point out here would be -12, maybe a fourth. This arm way out here would be -100, 1/10. So that second number, that y number, is getting closer and closer to 0, and it will never reach 0. Okay, let's look at the other two I inserted. As x progresses toward 1 from the positive direction, and I want to look at as x becomes 1 from the negative direction. So we're looking at x going to 1 from the positive and x going to 1 from the negative. Let's look at 1 to the positive. So as x becomes 1 to the positive, let's see. If we're trying to reach 1 and we're going from the positive direction, that means we'd be coming from this direction, from the positive direction. We're getting closer and closer to 1 on the x-axis right there. Well, there's an asymptote there, so we're not going to get to 1. But what is the y doing? Let's see. As we get here, we're at 3, -1/2. Here, 2, negative almost to 1. Here, 1.5, -1. As we get closer and closer to 1, here we go down here to negative infinity on the y-axis. So that's taking us to negative infinity there. Now as x goes to 1 negative direction, from this direction, as we go closer to 1, there's 1. We're not going to hit 1, but here's what's happening, that arm right there. So as x proceeds to 1 from the negative direction, what is the y doing? The y is going all the way up there to infinity. So I wanted to look at all three of those because I've looked at your test. This is why you come to review, you know, because you want to see what the teacher has to say about the test that the teacher made. Okay, let's look at number 2. Use transformations of f of x equals 1 over x to graph 1 over x plus 4. So let's start with, let's start with 1 over x. 1 over x is going to look like this and that will be close enough for us. It's got the little guy in the 1 quadrant and in the 3rd quadrant. Now we want this same thing, but 1 over x plus 4. So that's within the x, that's down there with the x. It says plus 4. You know that that tells a lie, that we want to go minus 4. So we're going to go, I'm looking at what I did here, it's weird. So we're going to go in the -4 direction. We're going to go 4 to the left. This is on the x-axis, that's the horizontal axis, and we're going to go 4 to the left. This point right here is at 1, 1. So we're going to scoot it over 4. 1 takes it to 0. 2 is -1. Let me just write them in here. So we're going to go 4 to the left. 1, 2, 3, 4. This is going to be the place where this is going to turn. So it's going to look like that. And then you can, you know you're going to have those there. So we're going to have that. You're not going to have to be super specific on this. You're going to have to know that it goes to the left, and you're going to have to know that it goes 4 to the left, and you'll be able to count them. Okay, number 3 is a mess. Number 3, we're going to graph 3x over x minus 4. So 3x over x minus 4, that's f of x equals 3x over x minus 4. Let me grab some information for you. Hang on a second. This is the list of things that we were looking at when we were doing these. This is the way to get this graphed. The first thing was the vertical asymptote. We will set the denominator equal to 0. So vertical asymptote, x equals 4. Move that 4 over, set it equal to 0, and move it over. So when we go to graph, x equals 4. 1, 2, 3, 4, right about there. That'll be our vertical asymptote. Second thing we're looking at here is horizontal asymptote. And there are the 3 rules. Let me grab that. Horizontal asymptote. Right here. The degree is less than degree of the bottom, degree of the top is greater than, and the degree are equal to. Know all 3 of those rules. In this case, we've got the degree equal on top as on bottom, so we've got it equal to. So the horizontal asymptote will be y equals the leading coefficient of the top over the leading coefficient of the bottom. So that's going to be y equals, and then we've got 3 over 1. So y equals 3. So let's say there's 3. We've got our horizontal asymptote right there. Next, we want to look at where does this cross the x-axis. Set the numerator equal to 0. So 3x equals 0, x equals 0. That's going to be one of the places that our graph will cross. Y-intercept, plug in f of 0. So if I put a 0 in, if I'm looking at, I don't want to use up my graph room. So f of 0 equals 3 times 0 over 0 minus 4. I'll get 0 over negative 4. So the y-intercept, f of 0 is 0. We already know that point. That's not going to help us out any. Additional points. Yeah, we need some additional points here. Let's see. We know what's happening at 0. We know we're populating this 4th quadrant, or the 4th quadrant when our asymptotes are drawn in. So let's look around here. Let's look at, we know at 4 we can't hit 4, but let's see what happens at 3. Let's put in a 3 there. So 3 times 3 is 9. 3 minus 4 is negative 1. So we get a negative 9 there. So let's see. 3, negative 9, way down here. You know what these things look like. They look like these guys. They look like little curvies. So let's assume that this is going to do that. Let's just check to be sure. I'm going to pull a number out here. Maybe this is 0, negative 1, negative 2, negative 3. Let's see what happens at negative 3. Put a negative 3 in there. Negative 9 divided by negative 7. So that's going to be a 1 plus, 1 and a little bit, 1.4, something like that. 1 and a little bit. So negative 3, 1, something like that. And that's matching what we thought would happen here. So we're looking at this. And then you can go and look and see what's happening. The same sort of thing's going to be happening up in this corner too. It'll match the opposite corner kind of idea. If you're not sure, grab a point. We know that 4 is not happening. Let's look at what happens at 5 right next door. Put a 5 in there. 3 times 5 is 15. 5 minus 4 is 1. So we get 515. So if we go out here to 5, we're going to be way up high there at 15. Let's come down. You know, we're expecting it to do this sort of thing right in here. Missing this asymptote, missing that asymptote. So let's look at what happens at, say, 10. 10 times 3 is 30. 10 minus 4 is 6. That gives us a 5. So if we go way out here to 10, we'd go up to 5, something like that maybe. This is 3. So we're doing, you know, what we expected to be doing. You probably won't have to go into as much detail as that. Once you get a little bit of it done, remember this is a matching test. You'll be able to see that the others don't look like, you know, once you get this piece in there, you'll see that if you know this piece, the only one of those multiple choice answers that looks right will have both of those. I mean, it's such an easier game on something like this when you've got multiple choice answers. Okay, let's keep moving. Number 4 asks you to solve and graph on a number line. 7x squared plus 25x is less than 12. Let's see, that's a quadratic. I'm going to move the 12 over. Minus 12 is less than 0. Now I'm going to after this equals 0, less than 0, it doesn't matter. Remember, the less than is only telling you what part of the graph to shade, what part of the number line to shade. This will give us our goalposts. So 7 is only 7 times 1. Let me put 7x here and x. I know the signs need to be different, so I'll just put a plus and a minus. That might not be right. We'll find out, and it's an easy fix if it's not right. And then I'm looking for two numbers that multiply to give me 12. 3 and 4 are the closest together, and usually that's what they want from you. Let me grab a pencil. So let's put 3 there and 4 there and see what happens. That gives us an outside negative 28x. That gives us an inside positive 3x. That's a negative 25x. Okay, so we've got the right middle term. We're on the right track. The numbers are in the right place. So 3 goes there and 4 goes there because I've got 25 for the middle guy. But I got a negative 25x and I wanted a positive. So just change the signs. The numbers are right. We got a 25, we wanted a 25, so leave the numbers alone. If the signs are wrong, change the signs. So that becomes a plus, and this one will be a minus. Now I have a positive 28x on the outside and an inside negative 3x, which gives me exactly what I wanted, the positive 25x. Okay, so set each piece equal to 0. X equals negative 4, and then move the 3 over and divide by 7, and you get x equals 3/7. So relative to each other, the positive always goes on the right, you know that. Now, here's where we're going to shade this. If it had an equal sign here, the two answers would be positive 3/7 and negative 4 with little dots on them. But we want the entire piece of the number line where the answer will be less than 0. Arrow that points in tells you to shade between them. And then we don't have or equal to. It doesn't say or equal to, so we are not going to use brackets. We can't include negative 4. If we include negative 4, we would get 0 is less than, well, here on this statement, we'd get 0 is less than 0, and 0 is not less than 0. So don't include negative 4, put a parentheses on both. So negative 4 to 3/7 with parentheses around them is the answer. Okay, number 5, we're doing the same thing except with a fraction. X plus 6 over x plus 7 is less than or equal to 0. I changed it to an equal to. If you printed out an earlier copy, you've got just a less than, but I want to look at or equal to, because that also makes the answer right. The answer was wrong otherwise. Same game, set each one of those equal to 0. So x plus 6 equals 0, x plus 7 equals 0. Then we're going to move each one across. So x is a negative 6, x is a negative 7. Plot those. And this says we want to go less than. So again, very similar to the previous one, we want to go inside. If it said greater than or equal, we'd be using the outsides, but this is less than, so we're using the insides. And then it says or equal to, so we want to use brackets. Problem is, you're okay to use a bracket up here. Negative 6 plus 6 will give us a 0, and 0 is less than or equal to 0. So I can use a bracket there. I can't use a bracket here. Even though it says or equal to, use a bracket and include negative 7. Look at the denominator. Negative 7 plus 7 is 0. A 0 on the bottom isn't possible. It's a domain error. We're not allowed to use negative 7. So this statement tells you you can't use negative 7. You're not allowed to use a number that will zero out the denominator. So we're forced to use a parentheses there at negative 7. Even though this says it's allowed to be equal to 0. But if you zero out the bottom, that ain't 0. That's undefined. So we're going to have to smooth it at the denominator, allow it at the numerator. So negative 7 to negative 6 with a bracket at negative 6 and a parenthesis at negative 7. Okay, let's grab our calculators. 6 raised to the 2.6 power is what we're asked to do. And I didn't tell you how to round it. Let's see what I did round it to. think 3 places as I recall. Yeah, 3 places. The problem will tell you how to round it. 6 humpy, 6 raised to the 2.6 equals, we get 105 point, and then so 485, that's the 3rd place. It's the 4th place that tells us what to do. It says round up. So 105.486. It's approximately 105.486 there. Okay. Number 7, graph by making a table of coordinates. F of x equals 6 to the x power. Let's see, remember when the exponent is an x, so it's in the x column where our set of numbers goes. 6 to the negative 2, that negative goes to the denominator, and then 6 squared is 36, so we get 1 over 36. Plug in negative 1 for the exponent. The negative says go to the denominator, and 6 to the first power is just 1 to the 6th, 1 over 6. 6 to the 0 power is a 1, 6 to the first power, and 6 to the second power. So negative 2, barely up. Negative 1, just a teensy-weensy bit more up. 0, 1, 1, 6, and 2 way up there. Looks like that, which is what all graphs of exponentials look like. 2 to the x power would be that same shape, just not quite as close there and not quite as steep. 10 to the x power would be much tighter in here and much steeper there. So it hugs each axis. Each of the axes gets hugged tighter the larger the number is. But they all look like that shape. That's all they're asking you to do. Make a graph by making a table of coordinates. So we're done with 7. Okay, number 8. We are looking at start by graphing 3 to the x power, and then graph h of x equals 3 to the x plus 2 minus 3. They're also looking for the asymptote, the domain, and range. Okay, let's make a table again just so you get a little bit of practice doing that. X, although it's going to look like this shape, that's what it looks like. The differences are so small between this set of this table of numbers and that table of numbers. So it's going to look like that. I mean, if we were comparing the two, there'd be some differences. But if you're looking at a multiple choice test, it's going to look like that for the f of x. So 3 to the negative 2, it says go to the bottom and square it. So we get 1/9. Let's see, let me put these in here first. And they're going in the x column because the x is the where the exponent is. The exponent is an x, so we're going to line our numbers up on the x. 3 to the negative 2 is 1/9, then 1/3, 3 to the 0 power, 3 to the first power, and 3 to the second power. So, I mean, it's virtually the same thing. Let's look at it. Negative 2 1/9, negative 2 1/3, 0 1, 1 3, and 2 9. So I'm just going to use this one. Good as any. This transformation tells me that I want to take each of these points and move it 2 to the left, because this is on the x, and you know that's always the opposite. So 2 to the left, and then the truth on this one, 3 down. Okay, so let me grab a different color pen. Let's use orange. This, I think, is the easiest point because it is at a crossroads. It's at 0 1. Both of them are whole numbers. 0 1, I'm going to go 2 to the left. So I'm going to go to negative 1, negative 2, right there. And then I'm going to go down 3. So 1, 2, 3, something like that. And then just draw this in. Shift that down. It will not be so detailed that you will have to be extraordinarily careful. If you know the shape of this and you can read this to tell you what direction to go, and my gosh, you should be by now. I mean, we've done transformations for a while. Just move it and you're good. Okay, we need the asymptote of this guy. So the asymptote of the first one was this line, y equals z. Let me do it in black since that graph is in black. That asymptote was your asymptote. Now it has shifted down 3. So the new asymptote is going to be y equals -3. See what's happened on the y-axis, or sorry, on the x-axis, on the shift down, on the shift in the y, right there. It's gone from y equals 0 to y equals -3. The domain on this orange guy, the domain here, this will go all the way to -infinity. And this line, although it doesn't look like it, it will continue. We're allowed to put in 3 to the 5th power, 3 to the 6th power, 3 to the 7th. It will continue to get, x will continue to get larger. So the domain is -infinity to +infinity. Range is a little bit weirder. Range is what are we using of the y-axis. So we're not going to use anything below right there. It's not going to come below that asymptote. So where is that? That's at -3. So we're going to start at -3 and go on up to infinity. That thing's going to climb all the way up to infinity. Don't use a bracket there because you know you can't touch -3. That's an asymptote. Definition of asymptote. You can't get to it. Okay, let's do the same thing with a fractional one. Number 9 is 1/2 raised to the x power. F of x equals 1/2 raised to the x power, and then we're going to look at g of x equals 1/2 raised to the x minus 2 minus 5. So we're going to transform this one also. Okay, let's see what we got here. X is where the exponent is, or the exponent is an x, so put your little numbers here. This one gets a little bit hairier. 1/2 raised to the -2. Let's see. 1/2 raised to the -2. Negative flips it, so this becomes 2 squared, which is 4. Then 1/2 raised to the -1. The negative flips it, so we get 2 to the first. 1/2 to the 0 power. Anybody raised to the 0 power is a 1. 1/2 to the first power is 1/2. And 1/2 squared is 1/4. Let's see what that's going to look like. -2, +4. -1, +2. 0, 1. 1, 1/2. And 2, 1/4. So it's the flip across the y-axis with a fraction. Okay, now let's do some transforming on this one. You can see that we've got an x, around the horizontal shift, we've got a -2. So we want to go 2 to the right. And then we've got a -5, so that's 5 down. I think it's easiest to take this point. You can take any of them though. We need to go 2 to the right, so 1, 2, and then 5 down. 1, 2, 3, 4, 5, something like there. And then just draw that in. Something like that. Okay, let's look at the asymptote for this one. That's going to be that line right there. It was y equals 0. Now it's going to be y equals -5. It goes 5 down. They're telling you what to do with the asymptote right there. Go 5 down from the original asymptote. Okay, and that's all that you're asked for on that one. Let's look at number 10. You got $10,000 to invest. Which of the two rates would yield the larger amount in 1 year? 11% compounded daily or 10.88% compounded continuously. So we're going to look at two situations. On this particular problem right here, you can see that I didn't give you the formulas, but I told you you're not going to have to memorize them. So they are on the test. I made sure, I looked. They are on the test. So you have to know which one to use though. So the first formula that you're going to need to use to come up with daily compounding, you're going to have to use A equals the principal times 1 plus r over n raised to the nt. For this continuous one, you're using a equals p times e raised to the rt. Both of those formulas will be on the problem, but it doesn't tell you which one to use. Okay, so when the only time you use the PERT formula is on continuous compounding. So every other time you're going to use this formula. So we're compounding daily. And you know, as I was doing this, I was thinking that we did not do it. I don't remember specifically doing a daily compounding problem. The thing with daily is, you know, there are 365 days in most years, but in banking we use 360 for daily. And I don't believe that that is a number that, I don't think we did daily counting when we did problems. You may have had it in my math lab, but I don't recall that. So this is a thing you'll need to know. Now, I know if you use 365, it's going to be close enough to the value on the multiple choice test that you're not going to miss the problem. So it's not going to make a big deal if you did not notice that. But 360 for daily, because it divides better. Back when we didn't have calculators and bankers used, I mean, it divides by 9, it divides by 2, it divides by 4, it divides by all kinds of numbers. So the total value equals 10,000 times 1 plus the rate, this is 11%, so 0.11, divided by the number of times, that's 360, raised to the number of times it's being compounded, times how many years? 1 year. This problem told you 1 year. So let's go grab the calculators. I like to start at the back here, 0.11. 0.11 divided by 360 equals, then add 1, just doing the parentheses, then raise that, humpy 360, raise that to the 360th power, and then times 10,000. And we get 11,162, 11,162.59, making it look like money. Okay, that's how much that $10,000 is going to make after a year at 11% on compounded daily. Now let's see what's going to happen if we compound it continuously but at a lower rate. So A equals 10,000 times E raised to the rate, remember you got to move the decimal point over, 1088 times the time, and that's just 1. Okay, we can go straight across on this one, but I kind of prefer to take care of the back end first anyway. So E, remember E is the second shift there, so second E raised to the 0.1088 equals, and then times 10,000. Getting a value there of 11,149.39. That's wrong. I did something wrong. Let me check my notes here. Maybe I didn't. No, I did. 1149.39, and the other one was, I don't even see my other. Okay, so we back off enough on the, I thought this one had 1 and it didn't. You see where your most money is, it's right here. So the 11% compounded daily is the winner there. You back off enough. Continuous is always the best deal if the interest rates are the same, but this one backed off enough off of the interest rate that the daily compounding won. Okay, so 11% daily is the answer there because you got more money out of it. Not a whole lot. I mean, what is that? That's 13 bucks. Let's look at number 11. Shifting over to logs, we've got log base 8 of 64 equals y, and they want it in its equivalent exponential form. So it's already set up. Do the little circle. 8 to the y equals 64. 8 to the y equals 64. That's all they're looking for. They're not asking you to solve it. They're just asking you to put it in exponential form. You can see that's an exponential because there's a variable in the exponent. And this is saying, what do you have to raise 8 to make him be 64, your brain can see it better here. You know 8 squared equals 64 because you're used to doing exponents. You're not so used to doing logs. But they're saying the same things. Those are inverses of each other. It's like 3 times 5 equals 15, and 15 divided by 3 equals 5. Those are inverses of each other. We're better at one than the other, for sure. Number 12 gives you 6 to the 5th power equals x, asking you to write that in logarithmic form. So put a log. Now you need the base. The base is the number that gets raised to the exponent, so we're log base 6. And remember, the answer to a log is always the exponent. So 5, the exponent, is going to go over there, and then we've got that other number. So this is saying 6 raised to the 5th power equals x, and that's what that says. You can, after you put these in place, you can do the circle to make sure you can get back to the original. Number 13, begin by graphing f of x equals log of x. That's common log. We know there's a 10 there. Then graph h of x equals common log of x plus 4. They want asymptote and domain and range. Okay, I'm going to rearrange this into an exponential because it makes more sense to my brain. So I'm going to name that y, and then I'm going to shoot it over to here, equals y. Get rid of that. Now I'm going to turn this into an exponential. You know that's a 10 right there. So 10 to the y equals x. So this is the same thing as 10 to the y equals x. Let's build ourselves a little t-table. The exponent here is a y. When the exponent is a y, that's where you want to put your little numbers. Life goes a lot easier. 10 to the negative 2, that brings it to the denominator and squares it, so we get 1 over 100. 10 to the negative 1, that's what we get for x. 10 to the negative 1, move it to the denominator, and then to the first power, we get 1/10 for x. 10 to the 0 power, 10 to the first power, and 10 to the second power. 1/100th, go out 1/100th on the x-axis, and then go down 2 on the y-axis. 1/10th, go out 1/10th and down 1. Go out 1, don't go up. Go out 10 and go up 1 and go out 100. So we're looking at that with an asymptote, and the asymptote running up and down here, x equals 0, is our vertical asymptote. Okay, h of x is the same exact log, base 10, but we're doing x plus 4. So on the x-axis, we're going to shift 4 to the left. So 4 to the left, remember it's opposite day on the x one always. So here it is at 1, 0. Shifting it 1 to the left lands it at 0. 2 to the left lands it at negative 1. 3 to the left lands it at negative 2. 4 to the left lands it at the right place. So 4 to the left won't take it to negative 4. It takes it only to negative 3 because it started at 1. So it's going to look like that. And then the vertical asymptote, instead of being x equals 0, the vertical asymptote is going to be x equals negative 4. X equals negative 4 will be the vertical asymptote. It goes, there it is on the x, 4 to the left. So from x equals 0, the asymptote goes 4 to the left also. From here, 1, 2, 3, 4 to the left. Domain and range, I think they want here. Yeah, they do. The domain, what are we using up of the x-axis? Well, we're not using anything of the x-axis over here left of negative 4. So negative 4 to infinity, be sure to use a parenthesis there because you can't hit negative 4. That wall tells you, nope, you're never going to get to negative 4. The range, this ponytail goes all the way down, and this one will eventually go all the way up. We're going to be going all the way up with it. We will end up on the y-axis being able to use any number there. So negative infinity to positive infinity. Number 14. Log base 6 of x minus 1 equals 2. Write that in its equivalent exponential form and then solve it. So rewrite it as an exponential and then solve for x. So let's do the circle. 6 squared equals x minus 1. 6 squared, we can handle that. Trying to solve for x, so move the 1 over. So we get x equals 37, and there's our answer. Because we're talking about a log, you need to check it. Remember, your problems are going to be in random order, so it won't be at the very end where the nasty logs that you have negatives of are going to come. This one could be your first problem, it could be your last problem. So be sure if you're doing log of something to make sure that something is positive. So put the 37 in there, 37 minus 1, that's 36. Cool, 36 is a positive number. That's a good answer. If this had been like negative 37, negative 37 minus 1 gives you negative 38, that'd be the null set then, because you can't take the log of a negative number. As it is, it's a positive and we're good. Okay, number 15 is that height problem that we did in class. You've got this as your model, 62 plus 35 times log, common log of x minus 4, that's crossed out there, 35 times the common log of x minus 4. Let me show you the problem. The percentage of adult height attained by a girl who is x years old can be modeled by that formula, where x represents her age, but just from 5 to 15. So none of y'all would be eligible to use this to determine your adult height. We've assumed that you had reached your adult height since you are adults. 4-year-olds also don't fall in this. So this formula, this model, works only for ages 5 to 15. And f of x represents the percent of her adult height. Approximate what percent of her adult height is a girl at age 10. So we're going to stick her age. Does she qualify? Yeah, 10 falls between 5 and 15. So we can determine the percentage of an adult height that a 10-year-old has reached by putting 10 in right there for x. So I'm going to put a 10 right there. 10 minus 4 is 6. So f of x equals 62 plus 35 times the common log of 6. Grab your calculator. So I think I'm just back here. I don't have to worry about what my calculator's doing if it's doing what I think it's doing. Log of 6 equals, then times 35 equals, and then plus 62. Also, we're doing it in order of operations, which is kind of sweet. 89%. So we're getting 89% of a girl's adult height has been reached by the time she is 10. Your problem will not deal with adult height, but it'll be the same thing. Grab the formula, plug in the number where it goes, and work it out. It's not difficult. It's not tricky. None of this is tricky. Got to know a lot of different things, but you know, you've done your homework. You're prepared. You're here in class, which reminds me, let me take attendance before I get too much further. There we go. Number 16, expand as much as possible. Got log base 16 of 16 over y. You have 3 rules. One that allows you to add if the logs are being multiplied. This one that will allow us to subtract when the logs are being divided. So let's separate that out into log base 16 of 16 minus log base 16 of y. And then you got to look, what exponent do I need to raise 16 up to a 16? Well, that's a 1. And there is no exponent that you can raise 16 up to make him be a y. So there's your answer. Log base 16 of 16 is a 1, because what's the exponent you need to raise 16 to make him be 16? That's just a 1. You know, that's one of those identity properties. Number 17. Expand as much as possible. Let's do this again. log base b of x to the 9th times y. This will take care of the other two properties. When they're multiplied together, exponents will be added. So log base b of x to the 9th plus log base b of y. Now you've also got the product property. We've got a 9, we've got an exponent being raised to the 9th power. So we're going to sling that 9 in front and say 9 times log base b of x plus log base b of y. And that's fully expanded. Number 18 is asking you to condense common log of y plus 16 times the common log of z. There is a little bit of a problem with one of them. Let me finish this one and then I'll talk about it. This says plus. They're both common logs, so let's say common log. We know we're going to be multiplying y times, the 16 needs to be put back in place right there, times z to the 16th. And there we go. The power in front needs to be put as an exponent. So we've got z to the 16th times y because this was a plus. There is one problem that you've got. The font I'm not real happy with TestGen. But let's say, did I write that down? No, it doesn't look like I did. I meant to. Let me see if it's here somewhere. No, I don't think so. Let me see if I can remember it. It looks something like log, like that, log of 2x equals something. And you were supposed to rewrite it maybe, supposed to do something with it. This wanted to mean log base 2 of x equals blah, blah, blah. That is, it just looked too high in the problem. There's nothing I can do about it, but it meant to be log base 2. What I noticed is if you thought this was a common log and used 10 and did 10 to the whatever equals 2x, you can't get one of the answers that is in the multiple choice. The only way you can get a correct answer is to think 2 to something equals x. So this is not as big as that. It's more like that, not even that small, somewhere between there and there. But they're giving you the base. It should have been a little bit smaller and fit down in here, and it looked like there would be a question. Do they mean it to be the base, or do they mean it to be that extra number? But if you think of this, if you thought of it as being 2x and think of that as being a 10, common log, you can't get one of the answers. If you think of it as being base 2, then you can. So file that away in your brain. If it becomes a terrible problem when I see the answers, then I'll deal with it. Okay, let's look at number 19. Use common logs or natural logs and a calculator to evaluate log base 14 of 20. Log base 14 of 20. Okay, you can look for a long time on your calculator looking for log base 14 and you're not going to find it. We don't have a log base 14 available to us. Back in the day, the back of your math textbook had all kinds of help for that, but we don't have that. We've got log base 10, and then up here we've got natural log, which is using E 2.7 as your base, but no base of 14. So we're going to have to alter this problem. We can either say common log of 20 over common log of 14 and get an answer for that, or we can use natural log of 20 over natural log of 14. They'll be the same answer. I'm just going to go after natural log. So there's ln. Natural log of 20 equals, then divided by natural log of 14, and I get approximately, because I'm going to round, 1.135. Let me see how far I rounded this one. This would be number 19. 4 places after the decimal, so 1, 3, 5. There's the 4th place. The 5th place tells me what to do, so I get a 2 there. Now be careful. If you do natural log of 20 divided by natural log of 14, your calculator thinks you want to put, it thinks you want to not take the natural log of 20 divided by the natural log of 14. You want ln of one over the ln of the other. So use an equal sign there. Natural log of 20 equals, get a num for that, divided by natural log of 14 equals. And then you'll get the right answer. You can also use logs. Log of 20 equals, divided by log of 14 equals, and you get the same exact number. But be sure that you've completed the log of 20 before you go down to the denominator. Number 20, solve for x. We've got 9 to the 4x minus 2 equals 81. Okay, you're going to have to come up with the same base here. We're going to have to make these guys match. And you know that 9, this is a cousin of 9. This is 9 to the 2nd power. This one is 9 to the 4x minus 2. Now that the bases match, we can set their exponents equal to each other and solve from there. Move the 2 over, we get 4x equals 4, so x is 1. So you've got to make these two bases match. You've got plenty of problems like that in MyMathLab to handle that. Number 21, I'm going to change this up a little bit, and if you're looking at the current my current review slide, you've seen I've changed it to this. Let's first do this one, and then we'll transfer to this one. This one is more like the one you've got on your test, and I was concerned about that 5, about you not knowing what to do with that 5. So let's start with this one, then we'll look at that one. Okay, so we've got 7 raised to the x power equals 19. They want to get they ask you to use express in terms of natural or common logs, then use a calculator for an approximation. So we're going to need to turn this into a log. I mean, we can play with it. 7 to the 1st power, 7 humpy 1 equals 7, you know that. 7 humpy 2 equals 49. We want somewhere between there. So we got to play with it. 7.1.3, you know, who knows. Let's find exactly. So let's turn it into a log problem. Log, we need a base. The base is 7. Then what we need is an equal sign. The exponent goes by himself. The exponent is the log of 19. Okay, now we're looking at a problem similar to number 19. Very similar to number 19. We need to either use logs or natural logs. I'll use logs. So we're going to turn this into log of 19, common log of 19, over common log of 7. Or, I mean, you totally can use natural logs if you're sort of in the mood to use the natural log. Let's see what we get. Log of 19 equals, divided by log of 7 equals, and then let's go ahead and round to 4 places, 4 places after the decimal. 5131, 4 is the next number, not big enough. And so we get that value. Okay, that's the original problem. Let me show you the one that, you know, this is why you're here for the review. 7 to the 5x equals 19 raised to the 5x. We're going to do the same thing. We're going to build a log problem. What's the base? 7 is the base, goes there, equals. The exponent is always the answer, and then 19 will go here. Okay, we want x there. We want to get x by itself. We're going to have to divide by 5, but let's hold off on that. We're going to need to do that, but let's first get this thing structured. So let's change this part to log of 19 divided by log of 7 equals 5x. Nothing different there. You know this. You know this from problem regular 21. We did it in number 19 also. But we've got this 5. So we need to divide both sides by 5, Divide that one by 5 and he's gone, equals x. That's what we wanted. Dividing this by 5 just means put the 5 down there in the denominator. So let me rewrite this. This is log of 19 over 5 times log of 7 equals x. When we divide this side by 5, it goes away and we're left with x. When we divide this side by 5, the 5 just joins the denominator. It's no big deal. We don't create an extra denominator. You may or may not have known that about math and numbers and stuff. So now we've got this problem to solve. Let's look. Log of 19 equals divided by 5 times, I'm not sure exactly how to do this. Log of 7, let's try that, equals, there we go. So x equals 4 places 2161, and there's our answer. But you'll be multiplying the denominator times 5. 5 times common log of 7. So I don't believe we went over that. That is standard math, but I'm trying to not assume that everybody knows all the stuff you're supposed to know, because everybody doesn't know all the stuff we're supposed to know. Let's look at number 22. Solve, reject any values not in the domain, give the exact answer. So we've got common log of x plus 16 equals common log of x plus 16. Okay, we're going to be okay if we can get 1 log on this side and 1 log on the right-hand side. We've got 1 log on the left-hand side. So common log of x plus 16 is ready to go. Once we get this condensed into 1 log, then we can pull the logs off and do the math. So this is going to be the common log of, remember when they're added together, actually multiplied. So this will be x times 16 or 16x. Let's put it in the right order, the order we would expect to see. But it's still just x times 16. Now they both are logs, so we can cancel the log part out. And we get x plus 16 equals 16 times x. Okay, this throws a lot of students, especially in developmental classes, because you want to bring the 16 over here. Well, if you do that, there's nobody on this side of the boat, and the boat will tump. You'll have nothing over here. So, see, we've already got the number. The number is already over here. Move the x's to the right-hand side. So minus x and minus x, and we get 16 equals 15x, still solving for x. There we go, 16 over 15. Now be careful, let's make sure that'll allow us to have positive numbers. This is about 1. 1 is close enough to our brains. It's a 1. 16 over 15 is like 1. 1 plus 16, yeah, that'll be positive. 1, that's a positive number, and this doesn't have a variable in it. So this is a good answer for us, 16 over 15. It's not going to make us take a log of a negative number. Number 23, same game. Common log of x plus 9 minus common log of 2 equals the common log of 3x plus 4. Same exact game as the previous problem. We need to get 1 log, we'll need to combine these, equal to 1 log. Well, over here it's not a problem. We got 1 log. Over here, let's see, that says minus, so I know that's a division problem. I can condense it and make it a division problem. X plus 9 over 2. Divide by 2. Cool? Get rid of those logs and set those numbers equal to each other. X plus 9 over 2 equals 3x plus 4. Okay, first thing we got to do is get everybody on the ground. We've got this guy that's keeping x plus 9 off the ground. So let's multiply times 2. Multiply that side times 2 and that side times 2. So here the 2's will cancel and we get x plus 9. Over here we'll distribute 6x plus 8. Let's keep solving this. I'm going to move the x's to the right. So I get 9 equals 5x plus 8. Now I'm going to move the 8 over here, minus 8 and minus 8, so I get 1 equals 5x, and divide by 5. So I'm getting 1/5 for an answer. Let me make sure that's legal. 1/5 plus 9, that's still going to be positive. This doesn't have a variable. 1/5 times 3, that's positive, plus 4 is positive. So that one works. Be careful though, if you get an answer that makes a negative log, you've got to reject it. Okay, that is it for our review. I will stick around until you are done, till you leave. If you have a question, please ask. You've got all the way till Friday to take your test. Thursday night, your homework will zero out, and I will, or deadline out, and I will pick up your bonus problems. Let's see, how many bonus? 8, I think, here. 1, 2, 3, 4, 5, 6, 7, 8. Yes. Yeah, there are 25 questions on the test, so each one counts a clean 4 problems. But I didn't, there's enough combining going on the review. So the review wasn't 25 questions, but the test will be. Good luck. All y'all, do well. Thank you, Chloe. You too. Yes, Gage, go ahead.